A pleasant welcome to all. Now we are going to study about FBus protocol video lecture and e-content created by author Mr. R.D.Sivakumar, MSc MPhil MTech, Assistant Professor and Head Department of MCom CA, INR Janaki Ammal College, Sivagasi. Co-author Ms. K. Yogeshwari, MCom CA, INR Janaki Ammal College, Sivagasi. FBus protocol. FBus protocol, it is controlled mobile to enabled embedded system. Most Nokia phones have FBus and MBus connection that can be used to connect a phone to a PC or a microcontroller. The extension of FBus protocol standard is European Telecommunication Standard Institute. The GSM of standard for FBus is 3.40v 7.5.0. Functions of FBus protocol: high speed of full duplex communication. The speed is 1,15,200 bps and 8-bit data bus and no parity bit, one stop bit. Why we go to FBus protocol? In MBus protocol has half duplex communication. MBus is slow speed, compare FBus protocol. MBus speed is 9,600 bps. MBus is used for one stop bit and one parity bit. Objective: a FBus protocol implemented in server side. The SMS to the mobile will get into the server via the data cable connected. Then corresponding activities performed with respect to the commands or requests in the SMS received. The server will respond to the mobile using the mobile connected to the server. The server will transfer the command or request to the corresponding PC. Every communication among the server and the mobile will be done using FBus protocol. How to connect the mobile to PC? It may be use of data cable. This is an example of how to connect mobile to PC. Nokia model supporting PC connection: Nokia 3310, Nokia 3315, Nokia 6110. And this is an FBus protocol format. FBus frame header format. Byte 0, it represents FBus frame, and byte 1, it represents destination address. Byte 2 represent source address. Byte 3 represent message type or command, and byte 4 and 5 or represent message length. SMS frame header. Byte 6 and 8 represent start of the SMS frame header. Byte 9 to 11 is send SMS message, and SMSC 12 bytes. Byte 12 represents SMS center number length, and byte 13 represents SMSC number type. Byte 14 to 23, it represents the SMSC phone number octet format. Transfer protocol data unit. Byte 24 is represent message type, and byte 25 it represents message reference if SMS deliver and validity indicator used. Byte 26 it represents protocol ID. Byte 27 it represents data coding scheme, and byte 28 represents message size is and hex and packed. Destination's phone number 12 bytes. Byte 29 represents destination's number length, and byte 13 represents number type, and byte 31 to 40 octet format destination's phone number. Validity period. Byte 41 is represents the validity period code, and byte 42 to 47 it represents service center timestamp. The SMS message. Byte 48 to 92 SMS message packed into 7-bit characters, and message 93 always 0x00. The FBus usual ending. Byte 94 packed sequence number, and byte 95 padding byte. Byte 97 and 97, 96 and 97 odd and even checksum bytes. How to identify the acknowledge frame, send message, received and delete. SMS point-to-point character mapping. This is the technical specification that describes the packing of 7-bit characters and shows the standard character map. Packing ASCII into 7-bit character is a pain, but is quite easy to do. This is an example. Convert into the hexadecimal and the right shift. After packing, again reverse it, the message hello is therefore when packed. And this is an FBus protocol layers. FBus protocol layers are short message lower layer, short message transport layer, short message relay layer and short message application layer. Short message lower layer, it represents SM_LL. It is provide the give to the service to the upper layer for SM_RL. SM_RL, it represents short message relay layer. It is performing the acknowledgement, store and retrieve the data. SM_TL layers consist of 3 fields: address length field, type of address fields and address value field of variable length field. Address length field, it is stored the address length, type of address and address value to be stored. It is integer, represents numbers. It is 1 octet and this is an type of address field and this is an type of number bits. SM_AL, it represents short message application layer. It is performed the message passing. It is containing maximum range is 4096 bytes. Sending SMS, point-to-point character table. It is compression method used for FBus protocol. It is performed both unpacking and packing the message. This is the technical specification that describes the packing of 7-bit character and shows the standard character map. And this is an example of message packing. And this is an example of packing and unpacking the SMS. And this is an character mapping table. And this is an number packing. And this is an SMSC packing. How to delete SMS message with FBus. When the phone gets sent a message, it send a SMS message received frame with the message attached. In this frame is the location where the message is stored. All you have to do is tell the phone to delete it. Sequence number generated 41 to 47. In the 7 byte to be generated the sequence number. Each and every message calculated, the separate sequence number generated until 47 byte. Suppose another 8 SMS receive means once again sequence number start the 41 byte and go to 47 byte. Byte 03 is message type and byte 04 to 05 is a message length and byte 6 to 8 is a SMS frame header and byte 9 is a delete SMS message and byte 10 is a memory type and byte 11 is a location where SMS message stored. Byte 13 is a packet sequence number and byte 14 and 15 is a odd or even checksum bytes. How to receive a SMS message with FBus. When the phone gets sends as SMS message, it sends a SMS message received frame with the message attached. The SMS send example above sends a SMS message back to my phone. The same phone sending the message. Therefore, below is the SMS message that was sent above, but now getting the received by the phone. The first line is an acknowledgement command frame. Notice how the destination and source address are now swapped. This message is 2 bytes long with the 2 bytes representing the message type received and the sequence number. How to identify the acknowledgement frame and the send message, received and delete. And this is an PC to mobile communication. Modules: FBus protocol implementation, point-to-point character mapping, mobile to PC communication, client and server communication, PC to mobile communication. FBus format. The FBus protocol format implementation is server-side and run in the background. It is to identify the received message or send message or delete the message. Point-to-point character mapping. It is a compression method used for FBus protocol. It is performed both unpacking and packing the message. It is used to read the packed messages. Comes to the serial protocol analyzer. Mobile to PC communication. Mobile to PC communication is held using data case. Data cable is connected from mobile to PC COM port. That connection is made to extract the information from mobile to PC. The COM port will wait for incoming messages. Client and server communication. After extracting the information from the mobile, the server communication with the corresponding clients. The server control the client through TCP/IP. PC to mobile communication. After the client passed information to server through TCP/IP, the server will give the responses received to the sender mobile automatically. Thank you.